In the previous video, we have discussed about low-level languages and high-level languages. Now we already know that high-level languages are more like English, that are easy for humans to understand. So in the last video, I have explained that there are many programming languages that are high-level languages, and some languages are compiler based and some are interpreter based, and some are hybrid also. So what does it mean by compiler based? What does it mean by interpreter based? We will understand this in this video. So the topic is compiler versus interpreter. Then also I will discuss about hybrid languages. So for understanding this, we should know what is the job of compiler and interpreter. What are the major tasks? Let us see. See, the task of this compiler or interpreter, whatever it may be, first thing is it will check for errors. Check errors, right? So this is the first thing. Then the second thing is convert into machine code. Convert into machine code. Right? So I will write MC as machine code or machine code language. See, high level language, it gets converted into low level language, that is machine code, which is understandable by machine. So compiler and interpreter, they do this job of conversion, right? And the third thing here involved is execution of a program, that is running the program. Running the program means, you know well that I already told you that the programs are brought into the main memory and they are executed by the CPU. So the machine instruction will come inside the main memory and CPU will execute it. That is execution, running of a program. Now, for these three things, let us understand this. See, when we write any program, like this is the program. So I will call this program as a source code. When you write any source code, then that source code may be having errors. So why you will have errors? See, you may be mistyping something, or you might have forgot some statements, or you have not written the statements properly. There could be some errors. Those errors are called as syntax errors. So whether it is compiler or interpreter, it has to first check that the code, that source code you have written is not having any errors. This is the first thing. And if there are no errors, then it will convert it into machine code. So majorly there are two tasks of compiler or interpreter. They both do this thing. Check for the errors. If the source code is error free, then generate machine code, right? Then third thing, execution of a program. If I talk about execution, compiler doesn't take the responsibility of execution, but interpreter takes the responsibility of execution. Compiler is not involved in execution of a program. Interpreter is involved. So these things all we will learn in detail, right? So step by step we'll learn everything about these differences between compiler and interpreter. So just keep in mind, these are the three major issues that are related to compiler and interpreter. Now let us compare them one by one. For comparison, already I have taken some program code here. This is the source code written in C++, and this is the source code written in JavaScript. So I have taken these two examples. C++ is a compiler based language. It is having a compiler, it's not having an interpreter. JavaScript, which is useful for writing web pages, it will be a part of web page and it runs inside browser. Mostly the websites, if you visit from your browser, if you check the code, you will find HTML and JavaScript there. So it's a common name, everybody knows about it. So this is used in web programming. This is interpreter based. So this is the source code I have written. This is not the machine code. So this can be understood by a compiler and human beings. This can be understood by interpreter and human beings. So I have taken an example of compiler based language and interpreter based language. Now let us understand the differences. See, if I have this program and I want to compile, means translate into machine code, then if I give it to a compiler, compiler will convert this code into machine code. And as you can see that I have written this program into two pieces, right? Two pieces are there. So like this is the add function, this is the main function. No doubt we don't know anything about functions right now, but I have just written the program into two pieces. So when the machine code is generated, it will generate two different pieces, that is machine code for add function and the machine code for main function. So only the thing that you have to understand here is that if you break the program into pieces, then the pieces will be generated in machine code also. That is important. Now, this is the machine code generated. See, this is the file first.cpp. So after compilation, we get some file, some intermediate files also, and finally we get a executable file, and we get first.exe file, executable file. So here on the hard disk, I have shown here first.cpp, and if you call a compiler, compiler will run in the memory and it will take this program file and understand and check that there are no errors. First thing, if there are no errors, then it will generate a machine code file, that is first.exe, and it will save it on the hard disk, right? So you will get a separate file called first.exe. This is first.exe. Compiler generates machine code. That's all. If there are no errors, it has generated the machine code. Job of compiler is over. Now, next step, I want to run. As I said, there are three things, right? Checking for errors, converting. No errors, converted. Now execution. If you want to run the program, now you can run this program, first.exe file you can run. And you can run it as many times as you want. You don't need a compiler now. Compiler has translated once, that's enough, over. Now you run your program n number of times. Whenever you are running your program, this exe file will be used. Source code is of no use now. And if at all you are making any changes in this one, then you can recompile, you get a regenerated first.exe file, and that will be a new program or a fresh or updated program. So it means compilation or translation of source code to machine code is done only once. This is the first point. And compiler generates a separate executable file. This is the second point. Then the third point is whenever you want to run the program, you don't need a compiler. Translation is done only once, because that's the reason you don't need any compiler when running the program. And one more important thing of a compiler is that, see, there are few lines, 1, 2, 3, 4, 5, 6, 7, 8, some 10, 15 lines are there, let us say. In these lines, if there is any error at some place, suppose if I start from here, 1, 2, 3, 4, 5, 4 lines are perfect and the fifth line is having any error, your program will not get compiled. Your program will not get compiled if there is any error. Though it is in fifth line, first 4 lines are correct, right? But it has to generate a complete machine code. It cannot convert into machine code. So these are the points about compiler. Let me repeat quickly. Compiler will generate a machine code file, separate file, and translation of a program is done only once. Compiler will not be there when the program is running, right? Mostly students believe that compiler will be there at the time of execution. Compiler will not be there. And last point is that if there is any error in some line, then the program will not get compiled. Now, coming to interpreter. So for explaining about interpreter, I'll just remove this and I will change these files. Now let us look at the interpreter. So for interpreter, I have some JavaScript code. Don't try to read and understand the code. Just some lines are there, okay? These are written in JavaScript. Now, how interpreter works? Let us see. See, this is suppose a file called my.javascript, that is my.js, and that file is present here. Then I also have a program called Chrome, that is browser, a commonly used browser. So I am using a name Chrome here. So this chrome.exe, this is a browser. JavaScript runs inside browser. It cannot run independently. Now, how this JavaScript works, how Chrome works as an interpreter for JavaScript. Let us see. See, first of all, for running this one, for execution of this one, so I am not saying translation or anything. Directly I am saying execution, third step. Remember this. I have to run Chrome, and inside Chrome, I can run that JavaScript. So I can open that file in Chrome. Usually we don't open the file from local machine. We get the pages from internet. But here, if you open Chrome, then you can open that JavaScript file. If it opens inside Chrome, then Chrome will be executing this code, right? Whatever it is, just leave it what it is doing. So this code can be executed by Chrome. So Chrome work as an interpreter for JavaScript. So now you can see how it works. First of all, Chrome will run. Then if you make it read this file, it will take the file. Then it will go through this file and it will translate it line by line. And after translation, it will convert into machine code. Yes. And also it will get executed. Chrome will execute it. Like C++ program, compiler will not execute it. Here Chrome is the interpreter for JavaScript. Chrome will execute it, yes. So how it will execute? It will not translate whole thing, then start executing. It will translate first line, execute, second line, execute, third line, execute. So line by line translation as well as execution. Now let us compare this compiler and interpreter. See, compiler will read the program. It will be generating machine code line by line only, but it will generate the machine code for separate entire program and make a separate file. But a browser, which is an interpreter for JavaScript, it will not create an exe file for JavaScript. So this is the first difference. Second difference, compiler just translate, it will not execute. But interpreter, that is Chrome, it will translate as well as execute. This is the second difference. Second difference. Third difference, if once translated into machine code, now you run it as many times as you want, you don't need compiler. Translation is done only once. But here, whenever you want to run JavaScript, you should call Chrome. Chrome will run it. Every time it will translate. So if n times you are executing, n times translation will be done. Interpreted language. Then, here if there is any error, then it will not compile. Here, if there is any error here, suppose in some line, then first two line definitely will execute. Interpreter will not stop because it is converting and executing, converting, executing. If there is any error at any point, then it will stop. So till there, it will execute. Interpreter will execute. Compiled program runs independently. Interpreted program runs inside interpreter. Interpreter. Now finally, concluding point. Who is faster? Compiled programs or interpreted program? Compiled programs are faster because they run independent as a separate program. Interpreted programs are not faster because they don't run independently, they run inside interpreter, context of interpreter. So they are slower. Which are easy to write. If there is any error in a single line, it will not compile, you cannot run. If there is any error in some line, then a line till before that line you can execute. So it's easy. So up to some extent you can see the program running, and at this place, okay, there's an error, I can remove it. So these languages are very easy. Interpreted languages are easier than compiler based language, right? So this is the difference between compiler and interpreter. Now I'll give you one small example. With this you can remember this entire thing what I have discussed. Suppose you are making a Chinese recipe or dish, you are preparing a dish. So you have a recipe of a Chinese dish. It is written in Chinese. It is written in Chinese. You don't know Chinese. I know Chinese and English. So I can help you. I can translate it. I can translate it. Right? So you want to prepare a dish. Now, what are the methods I can translate? First method. I can read that entire recipe and prepare an English version and give it to you. That's the first method. Then second method, I will take that Chinese recipe, read first line, translate it, and I will tell you, right? And you will also execute it. Means you are right now preparing a dish. I will say, take a vessel of this much size. Okay, you take it. Then take this ingredients. You take it. Boil, take some water and boil. You will boil it. So I am reading in Chinese, translating in English, and I am also getting it executed. You are doing it. This is the second method. Now let us compare them. First method, if I give you an English copy, then translation is done only once. And you don't need me when you are preparing a dish. Two differences. Right? And you can work independently. Right? Same thing, second difference. Now here, every time you want to prepare a dish, again you will come, oh Chinese, please translate. I will translate. Right? This one. And second thing, whenever you are preparing a dish, I must be there with you. You are not independent. That's it. That's how you can remember the differences. So if I translate and give you a separate English version on a separate paper, now that Chinese version you can keep it in shelf. You don't need it. You have the English version and you don't need me on that same recipe once again. But here you need me every time because I am translating and I am getting it done by you, and that's all. Work is over. So same way, this Chrome will come inside the main memory and it will take JavaScript and translate and get it executed by CPU. So this Chrome is myself, and this is Chinese recipe, and this is yourself who are executing. You understand machine code, right? In case of compiler, you called me, I took first.cpp and converted into first.exe. Now you don't need me. Whenever you want, you can execute directly that exe code. So these are the differences. Now, finally, let us talk a little bit about hybrid languages. Hybrid languages like Java or all .NET languages like C Sharp. Now these are hybrid. They have a partial compilation, that is first compiler will convert into bytecode, then later this is converted by JVM into machine code. So I'm not going to explain in detail, just briefly I'm telling you. They have two steps. Compiler is also there, interpreter is also there. JVM acts as an interpreter, right? This is an interpreter. Why two stages? Compiler will check what? Compiler will do what? It's not generating machine code. The compiler just check for the errors. If there are no errors, bytecode. Bytecode is error-free code. Then JVM will convert or translate into machine code. So two-step process. As I highlighted three things, right? Checking for the errors, translation, then machine code and execution, right? Third was execution. So compiler just check for the errors. Error-free, it's not machine code, it's bytecode. Then JVM will translate into machine code and also execute. So it's an interpreter. So interpreter for bytecode, not for source code. So these two steps are there for providing platform independency, or in .NET languages it is for language independency. These are the different topics. Anyway, just we got the idea that there are some compiler based languages, there are some interpreter based languages, and some are hybrid which have compiler as well as interpreter that take the benefit of both and try to provide some excellent features. So that's all about this topic. Let us continue with another topic in the next video.